Hey guys, so I got to be in my 6th period class yesterday, and I got to see enough to see that I think you really need some more help with the and compound inequalities before I try to go on to something else or before I give you an assignment on your own. So what we're going to do today is you're going to watch this video and we're going to pause as we go along, and you should have a worksheet that says 3-6 practice, compound inequalities, and it says Form K up in the corner. And what I'd like for you to do with that worksheet in front of you, I'm going to do some example problems that mimic those problems on the worksheet. So I'm going to do problem 1 on the video, and then you're going to do problem 1 on the worksheet, which is really similar. Then I'm going to do problem 3 on the video because there is no problem 2 on your paper. Yes, I do know how to count. But anyway, I'll do problem 3 on the video, then you're going to do pause and do problem 3 on your paper because they're real similar. So you get an example of every problem as we go through. Now, if you understood everything yesterday and you're ready to roll, then you can probably just ignore the video and do the worksheet today while I'm absent. But since I can't be in class, I thought it would help if I tried to help you get through your assignment today. So here we go. Okay, so problem 1 says a kindergarten classroom is allowed to contain between 10 and 25 students inclusive. Write this as a compound inequality and graph on a number line. So if the classroom is allowed to contain between, that's your indicator that we're putting some variable in the middle of a compound inequality. Between 10 and 25 students inclusive. Now, when we see the word inclusive, that tells me that we're including 10 and 25 in our boundaries. So we're going to put the or equal to symbol under our symbols. And notice that the 10 is actually smaller than 25, so that's the reason it says 10 is less than or equal to x, and x is less than or equal to 25. On a number line, we would just show, maybe here is 0, 5, 10, 15, 20, 25. 10 was here. A closed point at 10 and also a closed point at 25, and shade the value in between. Now, your problem 1 on your paper isn't this one. It's real similar. So you may pause now and try number 1 on your paper. The next problem on the worksheet is problem 3. The direction state is solve each compound inequality and graph your solutions on a number line. So that's what I'm going to do here. I'll solve and graph on a number line. I notice I've got a compound inequality that doesn't have a word, so I know that this is an and problem, which means I'm looking for an intersection or an overlap. My method to solve is try to get k isolated in the middle. So to get the k alone, I need to do something with this minus 4. Well, I'll use the additive inverse. The additive inverse is positive 4. So if I add 4 to this middle section of my inequality, I have to add 4 to all parts of the inequality. So 6 plus 4 is 10. Bring down the symbol. Bring down the k. Bring down the next symbol. 13 plus 4 is 17. So this solution is 10 is less than k is less than 17. And on a number line, let's say that 10 is here and 17 is here. It's all the values that fall in between 10 and 17. I probably should have used a different color. All the values that fall in between 10 and 17. Notice the 10 and 17 are not included in the solution. So pause and try number 3 on your paper. Problem 4 on your paper is real similar to this one. We're still going to solve and graph on a number line. So the problem here that we see, we need to get the y isolated in the middle, so we need to get rid of this positive 3. So again, we're going to be using the additive inverse. And if I do that to the middle section, I will also subtract 3 from all sections. So negative 8 minus 3 is negative 11, and negative 12 minus 3 is negative 15. Now this time, you should notice that instead of having less than symbols, we have negative 11 is greater than y, and y is greater than negative 15. A lot of times we really like to see this with less than symbols, so if I were to turn this around, I would put the negative 15 first, the y still goes in the middle, and the negative 11 goes on the right. This says negative 15 is less than y, and y is less than negative 11. Your problem on your paper is going to be real similar to that. So on a number line, let's say here's negative 10, negative 11, negative 12, negative 13, negative 14, negative 15, negative 16. Y is going to include all the numbers that fall in between negative 15 and negative 11. So go ahead and try number 4 on the worksheet now. Pause. Number 5 on the worksheet is going to look similar to this problem. Notice we this time actually have the word and we have 2 separate problems. So I'm just going to treat these as 2 problems, and I'm going to solve them both. So let's just look at the one here on the left. 4b minus 1 is less than or equal to 111. So I'm going to start by trying to get the b isolated, and I'll add 1 to both sides. So that gives me 4b is less than or equal to 112. To get the b completely isolated, I'm going to divide both sides of the inequality by 4. And 112 divided by 4 is 28. So there's my first inequality solved. Now I'm going to solve the second one. So in the second one, I'm going to try to, again, isolate the b by getting rid of this plus 1 with the additive inverse. So I subtract 1 on both sides, bring down 3b. 64 minus 1 is 63. And then divide both sides by 3. So b is greater than or equal to 63 divided by 3 is 21. So they're still joined by this word and. This is the kind that I really like to look at 3 separate number lines to get an overall solution. It just really helps when you're finding that solution to just write it out separately. So if we're doing that, if I write the first number line is all the numbers that are less than or equal to 28. So let's first of all say that this is going to be 21, 2, 3, 4, 5, 6, 7, 8. So everything less than or equal to 28 would include the 28 and go everything to the left of that. Now if I graph the second one, everything greater than or equal to 21, so if I put 28 here, 27, 26, 25, 24, 23, 22, 21 would be right here. Everything greater than or equal to 21 would include the 21 and include everything to the right of it. My overall solution is what would be overlapping if I put one of those on top of the other. Well, if one of them starts at 21 and goes up forever, and the other one starts at 28 and goes down forever, the overlap is everything in between 21 and 28. So there is my overall graphical solution, and I could write the overall solution algebraically this way. It includes all numbers that fall in between 21 and 28 inclusive. One thing to notice is that I put the least number or the smallest number on the left here and the greatest number on the right. Pause, try number 5 on your paper. This problem looks like problem 7 from your paper, and we again see that it's just one problem with 3 parts, but you should immediately notice that that division by 3 is going to have to be canceled. So I'm going to start by multiplying everything in the problem. All 3 parts get multiplied by 3. So 4 times 3 is 12. If I multiply this middle section by 3, then the denominator of 3 is going to cancel with this 3, leaving me with 12 plus k. But then I still have a 3 that I'm multiplying by this negative 5. So that gives me negative 15. So that's getting rid of the division by 3. And now our goal is to get the k alone in the middle, so I need to use the additive inverse of this 12. So I'm going to subtract 12 on all parts. So that leaves the k alone. 12 minus 12 is 0, and negative 15 minus 12 is negative 27. So this says 0 is greater than k, and k is greater than or equal to negative 27. Again, this time we've got our inequality symbols turned around, and I noticed that the smallest number is actually on the right, so we should rewrite this as negative 27 is less than or equal to k, and k is less than 0. That puts the smallest number on the left and the greatest number on the right, and writes our inequality with less than symbols. Okay? On a number line, this solution, here's 0, here's negative 27. I'm going to be lazy this time. So it includes negative 27. It does not include 0, but it includes all the numbers that fall in between those values. Pause and try number 7. And problem 8 is really similar. Well, problem 8 here is real similar to problem 8 on your paper. I just need to get the y alone isolated in the middle. So I'm going to use the additive inverse of 12 minus 12. What I do in the middle, I do on all parts. So 32 minus 12 is 20. And 6 minus 12 is negative 6. So this solution says negative 6 is less than or equal to y, and y is less than or equal to 20. On a number line, if I scale by 5s, and negative 5, negative 10, negative 15, negative 20, everything between negative 6, including negative 6, so negative 6 is right here, and everything going up to 20, including 20, so that's a closed point, and we're going to shade the intersection between those. All right, hopefully this little video will help you get through the worksheet today. So these are examples that follow exactly with the problems on the paper. Feel free to rewind, go back and rewatch any of my examples from on the video to help you with specific problems on your paper. So the 3-6 practice compound inequalities worksheet that says Form K in the corner needs to be turned in today. Good luck, and I'll see you next week.